Today we're going to look at a skill that is pretty much the anchor of everything that we're going to do in algebra. And that sounds a little bit overhyped, especially when you think about how you learn this in Algebra 1. But the skill of being able to manipulate equations to solve and to isolate a variable is one of the most important things that you can do in all of algebra. It will make your life so much easier between now and May. So solving linear equations. So some key vocabulary terms up at the top of your note page. The first is equation, a statement in which two expressions are equal. It's extremely important. The equal sign is the most powerful symbol there is in math. And you laugh at that because you think about in grade school, it really just meant, hey, put the answer here on this line. But in algebra, the equal sign says that this expression over here on the left and this one over here on the right have the exact same value, no matter how weird they look. So an equation is a statement in which two expressions are equal. A linear equation with one variable is an equation that can be written in the form a times x equals b, a and b are constants, a not equal to 0. And the other really key term to get a handle on before we do anything else is this concept of a solution. When we say solution, colloquially, we kind of just think like the answer to a problem, and that shovels down into the way we look at our math problems. But solution has a specific meaning to us in algebra. It's the value of a variable that makes the statement true. So this is an important thing to keep in mind. Two equations are equivalent if they have the same solution. So x minus 2 equals 1 and x equals 3, those are equivalent equations. How is it that they're equivalent? Both of them have the number 3 as their only solution. We have two tools that we can use to solve equations. The first one is inverse operations and the properties of equality. And these are like duct tape. They solve every single thing that we're going to do in this chapter. So the first one is inverse operations, and that's the one that we think of as undoing whatever's been done to the variable. So if I have x plus 7, if I subtract 7 on both sides, right, that undoes the adding of 7. And we also want to think about addition and subtraction. Those are inverse operations. They undo each other. 4 plus 7 equals 11. 11 minus 7 is 4. Similarly, multiplication and division are inverse operations. They undo each other. 6 times 3 is 18. 18 divided by 3 is equal to 6. Our other tool are what are known as the properties of equality. There's 4 of them. The addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. And they all basically say the same thing. If you start with an equal expression, a equals b, and you do the exact same thing to both sides, for instance, add c to both sides, then you still have a balanced equation. A plus c is equal to b plus c. Similarly, if we subtract c from both sides, that's the subtraction property of equality. Or if we multiply both sides by the same thing, that's the multiplication property of equality. The division property of equality holds if we divide both sides by the same thing. So here's our goal. When we're solving an equation, we want to work through systematically using inverse operations and the properties of equality to get an expression that looks like x equals something. We're trying to isolate the variable on one side of the equal sign. And you can do anything you want to solve an equation. Anything you want, as long as you do the same thing on both sides of the equation. So let's look at a pretty basic example first. And this is where things started to kind of fall apart for a lot of my students back in Algebra 1. You know, they find out they have these super powerful tools, and then they get an example that looks really, really obvious. And they feel like, I don't need to use tools to know the answer to this. X minus 8 equals 12. Like, okay, so what number, if I subtract 8 from it, equals 12? The confusion here is we start to do whatever math we feel like doing, grab the two numbers and subtract them, or say this is 4. That's not the case. Let's systematically work towards getting the variable by itself. So I look at x minus 8. So the variable is x. What's been done to the variable? It has 8 subtracted. What's the inverse of addition? Or subtraction, I should say. Well, that's addition. Gave it away. So I'm going to add 8. The property of equality says if I add 8 on the left side, in order to still have a balanced equation, I need to add 8 on the right. 12 plus 8, that's 20. Negative 8 and positive 8, when I add those two things together, those are opposites. they equal 0. What basically happened here is I now have x plus 0 equals 20, well, I obviously don't have to write the plus 0. So x equals 20. Let's look at another example. Negative 3x plus 6 equals negative 12. Go ahead and pause the video, work this one out, and then check your work with me. So now we've got a two-step equation. I have the variable multiplied by negative 3, and then that product has 6 added to it. Well, I'm going to save the variable term for last. I'm going to undo the adding 6. Now, step carefully here. Negative 12 and negative 6. I have 12 negative things, 6 more negative things. That's 18 negative things. Negative 6 and positive 6, those sum to 0. So negative 3x equals negative 18. Now I can tackle this multiplication. I'm going to divide by negative 3 on both sides. Negative 3 divided by negative 3 is 1, so this is 1x. That's what I wanted. Negative 18 divided by negative 3. Remember, I have the same sign here. This is going to be a positive product. 18 divided by 3 is 6. So x equals 6. Let's look at a couple more challenging examples. An example with variables on both sides. 3x plus 7 equals 5x minus 1. Now, if I'm trying to isolate the variable here, I have variables on both sides. I have to pick a side, and then I can still use my inverse operations and properties of equality to move one of those x terms to the other side. I'm going to go this way. Let's subtract 3x, because I'll end up with a positive coefficient. 5x minus 3x is 2x minus 1. It's going to look a little weird because my variable's on the right, but I can work with that. Now I'm going to add 1 to both sides. So negative 1, positive 1, that's 0. 8 equals 2x. Divide by 2, divide by 2. 8 divided by 2 is 4. So x equals 4. Let's kick it up one more notch. Now I've got distributive property. Whenever you have a case where there's a variable on both sides, one of the things you have to be aware of is it's possible that you could have an unusual situation of having no solution or infinitely many solutions. Let's be careful to see if that happens. So we need to distribute first. 2 times 5x is 10x. 2 times negative 6, negative 12. Similarly here, negative 4x, negative 4, negative 3 is positive 12, plus 4. Combining like terms, I have negative 4x plus 16 on the right, 10x minus 12 on the left. So let's add 4x. And then let's add 12. So 14x equals 28. And you could probably take it from here. So, much unlike our first example, when it looked like something that could really solve by observation, inspection, this one here, there's really no way that we could actually just look at it and guess, oh, I bet x is equal to 2 and that's going to be just fine. We needed to use the steps to solve this problem. The answer wasn't obvious. One last challenge for us is an example where we have fractions in the equation. You can tackle this a couple of different ways. You can add and subtract fractions from each other just like you can add or subtract constant whole numbers. But what a lot of folks would really rather do is take the fear factor out of this and eliminate the fractions. And the way that we can do that is we can multiply through by the least common multiple of the denominators, 2, 4, and 8. Now we're looking for the smallest number that's a multiple of all of these. In other words, a number that divides by 8 and divides by 4 and divides by 2. And it's pretty easy to see that that's 8. I'm going to take this entire equation and multiply by 8. So what happens? 8 times 1/2. Well, half of 8 is 4. 8 divided by 4 is 2 times 3 is 6. So negative 6. 8x, and here 8 divided by 8, that's 1, I'm going to end up with 5. So now, by multiplying through by the least common multiple, I've eliminated all the fractions. Now I have an equation with variables on both sides, very similar to what we had in example number 3. Let's tackle that. So negative 6 equals 4x minus 5. So when I add the 5 to both sides, I get negative 1 equals 4x. Dividing by 4 on both sides, I'm going to end up with a fractional answer here. X equals negative 1/4. So those were some increasingly challenging examples that all involved using inverse operations and the properties of equality and some previously learned skills like least common multiple and distributive property in order to solve equations. So take a moment now that you've worked through solving these equations to summarize what you've learned. 3 things that you learned today, 2 things you want to know more about, 1 big question you still have, and then anything else you want to do to help cement your learning, if it's sketch noting or connecting things back to things you've learned previously or in other classes.